Hello YouTube, HPZ here today, and yeah, I presume you guys never thought that you'll see this beast back on the table again. But for those of you that don't know, this is the Sedaa, the Sega Megadrive clone that I had. And I kind of made quite a few modifications to this off camera. I never made a video of this because, well, this was during a time that I was kind of depressed and I was just in a mood to just get stuff done. So I wasn't feeling too great. So what I would do is I'll open stuff up and just do projects for the sake of just completing them, because it's so much quicker and easier to do it without doing the stuff on the camera. I wish I could portray in words just how much time it takes to record and document something, even if it's something small. So the first little thing that you might get a glimpse of is, if you open this up, it's quite a bit different inside. I'm going to stick that there. Don't know if you guys can see that, but let's just, you see there's two USB ports in there. And if we take the cover off, because this, I'm not never ever going to screw this down again, because it's always nice to show people what's inside. So you can see there's been some changes, and basically the thing has sat on my desk neglected because I got to a certain point with it and I put it down like most of my projects. So the only part of the whole Sedaa system, which is that cheap Sega Megadrive clone that is on my channel. If you haven't seen the video yet, just type in Sedaa. You saw the spelling just now and you will see the spelling in the title, and you'll find my video about this. So the only thing that I kept here is this little motherboard that's in there. And I've added a few things, and I'm just going to give you a quick walk around of what I've added and why. So I'm just going to do it zoomed out quickly a little bit, and then I'll zoom in to give you guys a better look. But basically I've added a 2.5-inch hard drive that sits right there. A USB hub, which I desoldered all of the ports and resoldered two of them to be upright so that you can plug stuff in, and two of the other ports branches out to two devices, and we've got a Raspberry Pi 1 here. So let me zoom you guys in. So what you have here is a Raspberry Pi 1 Model B, because that's what I can afford. If you guys really want to see something better in here, you know, I've got my links to the Patron, I've got my links to everything else. Just send the funds to buy a Raspberry Pi B+, and I'll do an awesome project, awesomer than this with it. But yeah, so that's in there, and I'm just gonna take out this one old screw here. It does screw down nicely onto the case. Let's see if I can bend this way. So you can see there's a USB hub down there. And the hub goes off, and there's a Wi-Fi. You can't see it, there's a Wi-Fi there. And just underneath the hard drive there's a Bluetooth module. So those are permanently wired in. And my biggest problem with all of this is it looks great, but the GPIOs for the controller is something that I never got around to actually connecting. So what I want to do today is connect that so that I can like plug it in and stick in an original Sega Megadrive controller and play some games the way they're meant to be played. This is mainly due to the limitations of the Zero. I'm not going to, the Pi 1, I'm not going to expect it to play like 3D games like PlayStation and N64 that great, but I'm going to expect it to work. Now, a few of you are probably screaming at me about my design decisions here, especially due to the hard drive. I started this project about 2 years ago, back when flash memory was still quite expensive. So the main idea for having a hard drive, and hopefully I can get that working again, I've got another 60 gig drive that I'm formatting right now just for this, is that I'll have a 4 gig SD card in the actual Pi. And then that goes over to USB to the hard drive, which I can get cheap SATA hard drives, and I can fill that up with ROMs, games and stuff, and it'll load the games from there instead of from the more expensive memory there. So I hope that that's still going to work, and I can make that work somehow. But as you can see, our biggest problem is going to be getting everything connected. I'm going to be cleaning this out, of course. So the biggest problem is going to be getting everything connected on here and making sure everything works. So what I'm going to do is I'm going to do a lot of this off camera. But what I need to do is I need to go and look at the pins here, turn the board upside down and just see where they are connected on the traces and just map out what's what here. Okay, so we know that the first two is like the power switch, but I don't know the reset switch. Where is that connected? What does that go to? What's the rest of the pins here? That sort of stuff. So what I'm going to do is I'll do that off camera. I've got a ribbon cable here as well. So I'll use a Sharpie and I'll just mark which cable is which, and then I'll solder this in. And then break that out and then solder that to the Pi. I've got some other pins that I'm going to use. But the main reason I'm doing it this way is this needs to be done as cheap as possible, and with the stuff I've got. I can go out quickly and buy an SD card, but financially I'm not too great at the moment, so I really don't want to spend any money on this if I can avoid it. So I'm just going to do my best, get most of this working, and then hopefully we've got a nice little thing that we can play with and that sort of stuff. So yeah, I'm going to solder this in there, and I'll see you guys when that's done. P.S. While you wait for me to do this, I think I've still got some photos of when I made this, because I did document it with photos. I'll probably put in a slideshow while you wait. Because this is going to be the hardest part of this, is going to be tracing out what all of these pins do. I think that's reset there. Reset and reset. Yeah, it has to be. Yeah, there we go. Those two are reset. Okay, so yeah, let me desolder everything here, and if those two are reset I can probably skip that pin, and then we can get going, so to speak. Right, so I've reversed engineered these pinouts. I haven't soldered anything yet. So you can see it's basically 20 pins that come out there. Okay, it breaks out into 20. So let's just go over this quickly. And I'm going to zoom you guys in, because this is going to be a big mess, because for whatever reason the instructions on ooh, I've got a message. Anyway, the instructions that were given on RetroPi's website, these buttons don't make any sense. It's not standard Genesis buttons, so I need to figure out how to convert that. But let's just zoom in here so that I can show you guys what's going on there. So hopefully when I flip this over it'll be the right side up for you guys. But basically what we've got here is power. So that goes to a little power switch at the side, so I use that for power for the system. Ground, reset ground. Then on player 1, all of these are player 1, it's pin number 8, 9, 1, 2, 3, 4, 6. Okay, player 2, all of these are player 2, which is nice that they like grouped them like that. And then we've got the same thing mirrored again, 8, 9, 1, 2, 3, 4, 6. So you'll notice that there's no pin 5 and there's no pin, what was the other one? I think it's 7. Yeah, there's no pin 5 and there's no pin 7. Okay, and the reason for that is actually pretty clear, because pin number 5 is all ground if I'm not mistaken. Let's just double check that. Okay, so I've got this here, and we can see that pin number 5, it's all ground. Oh, pin number 5 is actually all power. Good thing I checked that. I didn't lay you guys into this array there. And pin number 8 is all ground. So now I need to figure out where these go to there, especially with this weird fire I mean, this doesn't make much sense. Fire 1, 2, 3. So I'm hoping it's on the Genesis controller, it's in the right order there, because you can see this is shared with another pin, and that's shared with another pin. So I don't know why they kind of labeled it like that. It doesn't make sense. So I'm just hoping that it's shared correctly and I can figure that out. So I'm going to fill in on this side now what pin it goes to on there, and then we can start soldering and wiring stuff up. Right, so back again, and this took way too long to do because the online documentation from the GitHub for this is half-baked. It's for a universal DB9, so hence why Fire 2 and Fire 3, they don't exist on a Genesis controller, not in the standard. So what you need to do is you have to go to the README and then read about what's going on there. And what's important there is pin number 7, but we'll get back to that shortly. So the pinouts look as follows. So this is looking from above, so looking the way that I'm going to have it soldered up in a minute or two. You've got power, so it goes to the power switch, ground, then reset, then ground as well. Now what's important here is these two grounds are linked, and it also goes to reset, and it goes to all the controller pins it's supposed to be ground, which is what you expect. Then you've got pin number 6, 7, 1, 2, 3, 4, and then 9. These are all for player number 1. Player number 2 is a mirrored of that, so it's 6, 7, 1, 2, 3, 4, 9. And then at the last one is 5 volt, it's FCC. So the Genesis controllers expect 5 volt. I'm going to supply it with 3 volt because of the GPIO limit on the machine. So I'm hoping that works. And now we've got the pinouts here. What's important is you'll notice that pin number 5 is missing here. 5 is actually your power pin. Now pin number 7 is a mode detect pin. Now this detects between a 6 button and a 3 button Genesis controller. I'm going to use a 6 button here. So that goes to select 0, and to find this you need to go to the README on the actual application, not the README on the GitHub. Okay, so what I did here is I had a look at the buttons. So player 1, player 2, up is 1, down is 2, left is 3, right is 4, fire 1 is 6, not pin 7, then it's 9, and pin number 7, which is our select 0, which selects between 3 buttons and a 6 button. Now it should automatically select between the two, because I see this is select 1 is also collected here, so it probably does some sort of readings and figures its own thing out. You know, I don't think it needs any help there. So I'm quickly going to wire this up, and I'm going to desolder all of that, solder in the new wire, and Bob's your uncle hopefully. So let's get started on that quickly. Right, so several maddening hours later I created this harness. I have no idea if this works, because the first attempt turns out was not 100% correct. Some of the wires wasn't soldered in correctly, had the correct pinouts, etc. So as a result, like, direction buttons worked, but everything else was a no-go. So I decided to, instead of sitting there for hours debugging things, I decided let's just rather make a nice harness for it like that, so that everything, this wire is in the middle of, no shit, I'll fix that later. You know what, let me just fix that now. Okay, that's there. 3.3, which is the most important thing, is there. Nothing shorting. Okay, first test. Let's plug this in. Okay, so this is working now. I figured out why it wasn't working. For whatever reason, the Orange Pi, Raspberry Pi, I'm so used to working on Orange Pis. The Raspberry Pi decided that my keyboard layout is UK. Who on earth does that? I mean, just switch it to US International. Oh, I took too long. Okay, nonetheless, so what we're going to do here is I'm just going to go to this page here. And this is basically what we use to configure everything. So yeah, okay. So there we go. Introductions, interfaces, usages. Okay, so the one we want is 6 buttons plus 2. I don't know why it's 5 plus 1. Whatever. Okay, so we're going to go up here to installation. Okay, the devices are loaded, unloaded. What installation here? The easiest way to install is with the script and manage packages, then manage driver, then game. Alternatively, there's a .dev with files to download. You can directly download here. All of this is pretty much useless because I can't go into the configuration. You can actually RetroPi config over SSH, because I'm sure you guys want to see what I do. Okay, I've already enabled that. Don't care about Berryboot. Connecting, yada yada yada. RetroPi setup scripts, that's fine. That's what I want. So grab putty 10.00122. Fine, wasn't it? What was the default username and password? By Raspberry, okay. I hate putty. There we go. If anyone knows of a better SSH program than putty, something with the screen on this side, connections on this side, and when it closes, it doesn't close the whole thing. So let's just see. I might have to quit it on this side. Let's. That should work. Package manager. Manage optimal. So let's see what we're looking for here is manage driver packages. Okay. Control book, custom file bank. What is this called? GPIO modules. Game controller driver. Okay. Why have a different name there to never mind. Oh, I'm over the intensities. Okay, we said that it was controller, game controller driver. we wait. So I do actually have a copy of the README somewhere. Where did I copy that? Yeah. So while that's busy, the thing I dislike about this is it says you need to install it first before you can actually see the README. So let's go here to DB9. So in order to read more, in order to see what the hell is going on, you need to do that. But I need that before I do anything else, and I know what's going on. Anyhow, here we go. So, Megadrive, Genesis, there's my GPIOs. So Genesis is 3.3. Okay. And then configure the driver. Configure the joysticks. First time, RaspberryPi, map port 1, map port 2, where it describes a joystick type. Okay, so I want Genesis 6. So 6,6 is what we want here. So let's go back to our PuTTY installation. DKMS, install complete, it's building again. God, this thing is a troublesome thing to get through. You guys haven't seen it yet, but it's been a good 2 to 3 hours that I've been busy. So I'm probably just going to stop this recording so it doesn't eat up all of my hard drive space, and then I'll start it again when I'm ready.
Right, so I'm back again, and what you guys don't know is it's been about a week since I started recording this, and I'm just going to edit this in the correct place, and just there's a bit of an addendum here. So here's the official instructions from the latest build of the DB9 driver for the Raspberry Pi GPIO. So you follow this and you set up everything, and you get to about this stage. So you type in mod pro first time, and in mine worked out to 6,6 because Megadrive Genesis 9 or 6 button was my default controller. So you type this in, and then your controller works, and then you read further down, and what they suggest you do is that you need to edit. Where is that? If you when using mod pro, okay, here we go. So it says here, when using mod probe, okay, the configuration does not persist over reboot. Okay, to configure the driver to be loaded on startup, add the driver name and joystick map to etc modules. So you use nano and you add this. It sounds straightforward. It sounds easy, doesn't it? It sounds like something that anyone can do. But unfortunately, if you dare do this, okay, it just doesn't persist over reboot. So what I had to do is I quickly jumped onto their forums, and I posted here, I've got a strange problem, I've edited the thing, that's what my configuration file looked like after I've edited it. And the problem with this is, okay, I thought maybe it's going to take the second joystick, so I made it 6.0. And yeah, you restart the machine and your controller stops working. That's quite a big deal. So I then tried to just create something just to run the mod probe script every time you start the system, and that didn't work because it would start up before the driver's loaded. So clearly there was something wrong. So I had to follow the Chinese whispers, and eventually it dawned on me and some other readers that the way that RetroPi loads drivers changed. So etc. It will not allow you to put the whole drive in. So what you need to do is you need to do it in two places, and I'll quickly show you guys how to do that. Now I've already done mine, so I'm just going to go first into my modules directory. Okay, and as you can see, this is what my modules looks like now. I've only got DB9, GPIO, or Raspberry Pi in here, because the way the modules work is it doesn't allow switches in here anymore. So you just have to do the actual driver you want to load, and it'll load it. I also uncommented Gamecom GPIO or Raspberry Pi. Now this is for Sony PlayStations and SNES controllers uses this driver. It's basically the same driver as that, just a different variant. But if you load both, then the system detects that there's 4 joysticks, and you don't want it to do that. You just want it to do one joystick. So you then have to go into sudo etc modprobe. So basically the modprobe directory has its own configuration space. So I'm just going to copy this and just show you guys what that looks like. So when you go into this, now you can add options. Now options is whatever else is supposed to go after that driver load. So you say options, DBI, GPIO, the driver name again. I don't know why you have to do that, but you have to. And then you say map equals 6,6. That's my map. And after you've done all of this, then suddenly the system jumps alive, and every time you reboot, it loads your driver correctly and everything works. Now what really boils my blood is this still actually has like commits. This database is being worked, or this drive is being worked on a monthly basis on GitHub. And for whatever reason, they just don't want to update the instructions for the DB9. I think the instructions are updated for the conventional SNES PSX controllers, but the DB9 ones aren't updated. It gives you this rubbish. And no one is responding on their forums. You can see that there is someone, Marks here, responds every now and then, and his last response was in August 13th. I posted in September 29th. No one responded, and I figured out how to fix it on October the 2nd by literally following Chinese whispers. And that's one of the things that really concerns me about Linux in general and GitHub is there's all of these absolutely amazing projects, and if someone isn't there to update them and to commit and to release them, they break down and they stop working, and there's no proper instructions on how to get them working again. So it becomes a huge task just to get stuff to work. But anyway, I'll cut back to the camera. I did in the interim redo the wires just to make sure it wasn't my wiring or anything like that, which, spoilers, it wasn't. But yeah, I hope you guys enjoyed. Cheerio.
Right, so it's been several days and there's some changes that I made here. Namely, I neatened up the wires. I added a little proto board and I soldered to the proto board with the headers underneath just to make it so that it's a module that you can just like pull out and put back in as you need to. So it's a lot neater now. I also took out the hard drive. I don't know if I'll keep the footage in from when I took that out. That was a bit gruesome. But yeah, there's a lot more space now in here for added things, and later on I want to add the reset, so I've just got that hanging loose there. But basically the most important thing is this, so I hope you guys can see there. So if I do that, thereabout, and as you can see, here's my controller. Absolutely perfect, and there's no delay or anything like that, so we can go in. Let's go up and start X-Men, but it just works. It works absolutely perfectly. So that's how you get a Sega Genesis controller to work on your Raspberry Pi with a lot of hard work and debugging. So there's X-Men. I think I accidentally selected 2 players. Oh no, I didn't. But yes, it works fine. I've got the buttons more or less mapped where they're supposed to be. And yeah, The rest is just software, literally. Okay guys, until next time, cheerio.
As of the YouTube apocalypse, none of my videos are monetized. If you enjoy my content, can you please consider supporting me either via Patreon, or if you just want to make a once-off donation, you can do so via Coffee. Both of those links are down in the description, and any support would greatly be appreciated.